There are moments in deep space exploration when the universe behaves exactly as our equations predict. Everything unfolds according to the physical laws that scientists have tested, refined, and trusted for generations. Then there are the rare moments that refuse to fit those expectations. Moments that seem to challenge our understanding of nature and force researchers to ask new questions. Voyager 1, the most distant human-made spacecraft ever launched, has experienced several remarkable events during its journey, making it one of humanity's greatest scientific achievements. For nearly half a century, Voyager 1 has traveled farther and farther from Earth, passing beyond the influence of the giant planets, through the outer reaches of the solar system, and eventually beyond the heliosphere, the vast bubble created by the Sun's magnetic field. It now operates in an environment filled with intense cosmic radiation, extremely low temperatures, and conditions no spacecraft had ever explored before. Against all expectations, Voyager 1 continues to communicate with Earth. Every faint transmission it sends travels for more than a day before reaching NASA's Deep Space Network. Each signal provides scientists with invaluable information about interstellar space, a region humanity had never directly sampled before. Imagine the universe as an endless ocean. Voyager 1 is like a tiny bottle drifting across unfamiliar waters, carrying a message from Earth into the unknown. Every piece of data it returns offers another glimpse into an environment unlike anything previously observed. As we follow Voyager's incredible journey, from the storms of Jupiter and the rings of Saturn to the icy worlds of Uranus and Neptune, and finally into interstellar space, we discover how this aging spacecraft continues to reshape our understanding of the cosmos. When Voyager 1 lifted off in 1977, its mission was expected to last only a few years. Engineers designed it to explore Jupiter and Saturn, capture images, transmit scientific measurements, and eventually fall silent as its power slowly faded. Instead, the mission became one of the longest-running scientific expeditions in history. Powered by radioisotope thermoelectric generators fueled with plutonium, equipped with 16 small hydrazine thrusters and a high-gain antenna measuring 3.7 meters across, Voyager has continued operating far beyond its original design life. Although many of its scientific instruments have been turned off to conserve energy, several remain active, continuing to collect valuable data more than 155 astronomical units from the Sun. Compared with modern spacecraft, Voyager's onboard computer is remarkably limited. Its processing power and memory are tiny by today's standards. Yet careful engineering, precise navigation, and decades of dedicated mission support have allowed it to survive in one of the harshest environments ever explored. Today, Voyager serves as humanity's only active outpost in interstellar space. No previous spacecraft had ever ventured this far, making every new measurement scientifically significant. Voyager's first major discoveries began at Jupiter. When it arrived, scientists witnessed a world unlike anything previously imagined. Massive storms stretched across the planet's atmosphere, lightning flashes dwarfed those on Earth, Io's volcanoes erupted continuously, and Jupiter's powerful radiation belts challenged the spacecraft's instruments. These observations transformed planetary science. They revealed that giant planets were far more dynamic and complex than earlier models had suggested. Within the enormous amount of data collected around Jupiter, researchers also encountered unusual electromagnetic variations that required further analysis. Most were ultimately explained through improved models of Jupiter's magnetic environment, demonstrating how exploration often uncovers mysteries that take years to understand. Voyager's encounter with Saturn marked the end of its primary planetary mission. Its cameras revealed intricate structures within Saturn's rings, while its observations of Titan exposed a thick atmosphere hiding a mysterious surface that would not be explored again until the Cassini-Huygens mission decades later. After Saturn, Voyager's trajectory carried it permanently away from the planets. The sun gradually appeared dimmer, communication delays increased, and the familiar environment of the solar system slowly faded behind it. Ahead lay an entirely different region of space. Meanwhile, Voyager 2 continued exploring Uranus and Neptune, discovering worlds unlike any previously visited. Uranus rotated almost on its side, possessed an unusual magnetic field, and displayed surprisingly complex atmospheric activity. Neptune astonished scientists with winds exceeding 1,300 miles per hour and the enormous Great Dark Spot, while its moon Triton revealed active nitrogen geysers erupting across its frozen surface. These discoveries demonstrated that planetary systems can behave in extraordinary ways, expanding scientists' understanding of how diverse the universe truly is. As Voyager 1 moved farther outward, it approached the heliosphere, the enormous bubble formed by the solar wind that surrounds our solar system. For decades, researchers had developed theoretical models describing this protective boundary. Voyager became the first spacecraft capable of testing those ideas directly. Its measurements showed that the heliosphere was not a smooth shell. Instead, it changed over time as solar activity varied, producing a complex boundary influenced by magnetic fields, plasma flows, and solar cycles. Gradually, Voyager measured the weakening solar wind while detecting increasing numbers of energetic particles arriving from interstellar space. These observations confirmed that the Sun's influence eventually gives way to the broader environment of our galaxy. Eventually, Voyager crossed the heliopause, the outer boundary separating the solar wind from the interstellar medium. Scientists had debated what conditions would exist there. Instead of a simple transition, Voyager encountered a remarkably active region where magnetic fields, plasma densities, and energetic particles interacted in complex ways. Its instruments detected plasma waves, changing magnetic conditions, and unexpectedly dense interstellar material. These measurements fundamentally changed scientific understanding of the region surrounding our solar system. Beyond the heliopause, Voyager entered true interstellar space. The spacecraft now measures an environment filled with high-energy cosmic rays originating from distant stellar explosions, along with plasma shaped by the magnetic structure of the Milky Way. These observations revealed that interstellar space is far from empty. Instead, it contains dynamic plasma, magnetic fields, and energetic particles moving through the galaxy in ways scientists continue to study today. Among Voyager's most valuable instruments is its plasma wave subsystem. Rather than detecting sound directly, the instrument measures oscillations in plasma that researchers can convert into audible frequencies. NASA has released several of these converted recordings, allowing the public to hear the changing plasma environment encountered by Voyager.